This is about the vernier calipers, which even though nowadays there are digital ones that you don't have to use the vernier scales to read the value of, they still have the same kind of way of building the measuring device itself. This is a Java applet I made with Fizzlets, and Java is getting more and more difficult to get working on any browsers. So I thought, I think I'll make a video of this thing, though it would have been nice to have people be able to run the simulation itself. You learn by doing, not just hearing, but I'm going to make a film based on this anyhow. Here's a calipers. Check the caliper 0, push the jaws together. Okay, check the 0. You talk about how to do this, why you do it. In general, it's important to check the different machines you use, like, for example, a scale for measuring weights, that it reads 0 when there's nothing on it. If it doesn't do that, you know they have to do some corrections of your measurements. And the way you check this one is by closing it completely. And if the 0 line is on the 0 there, then things are okay. Otherwise, you have to sort of record what could be wrong with it. On the digital ones, there's a zeroing button so that you can zero it if it's not showing 0. And the way you do it is, if you want to measure the outside diameter of something, you put it in here, and you pull it like this, and you get your value of how big it is. Like this is something about 13 millimeters. Okay. Now, I've got the different principles here. Here I have a complicated shape that's cylindrical. It has a cylindrical hole in it, and so if I want to take the different measurements, I would put it in between the jaws and close it like this, and then read off the value here. I'm not going to go into the reading of the vernier scales here. And then if I want to measure the internal diameter, like in this hole, I put these jaws on the opposite side into the hole itself, and then pull the jaws apart, like this. And then I can get a measurement of how big it is. So see, this is like about 7 millimeters approximately. I'm not going to exactly measure that. Then the question is measuring how deep the hole is. Well, that's where this part of the caliper is used. You put the bottom of the caliper against the edge of the hole, then you pull the jaws apart so this tongue goes down to the bottom of the hole, and when it reaches firmly the bottom of the hole, it's still connected here. Then you can read how deep the hole is. Alright, now there's a couple things about the way this thing is made. There's a common kind of mistake you can make, like if you have something that's small enough to be able to be put in this part of the jaw. If you close the jaw, you see that these two were actually the same size, but you see that if it's in there, you won't get the proper measurement. And you have to make sure that you have the thing you're going to measure between these parts that close when you check the zeroing of it. And this space is there. Why would they have this space there? To make things more complicated. So if we try measuring something, often something can have like some kind of deformation near the edge. Like, for example, a tin can have a furrowed edge or something like that. And if I try to measure the thickness of the wall, if I just have these jaws that go strictly together, they'll be going on the edges of this deformation there. So it'll give me a value that is bigger than the actual thickness. So these cutouts here are used so that if I want to use the cutout, I put the thing in so that the part that has the constant thickness is here, and the part that's a little bit deformed is in the cutout. So then when I close this, it will go completely onto the edge here and give me a proper measurement. So, now we know what these three jaws are for. This is for outside diameter, inside measurements, and for depth of holes measurements. Okay. You could see interpretations and answers and so forth in the Java applet itself, but I'm not going to go into those now.